What's up, people? It is your host, Aphelion, and welcome back to Ephemeris, the astronomy podcast. Um, I've been very busy this week, and admittedly, I am recording this episode on Sunday morning, trying to get it out, squeezing it in there a little bit. But, yeah, I'm afraid that because of how busy I'm gonna get, writing episodes, getting them out might not be as feasible. We might have a couple of missed weeks, but I'm going to try my best to make that not happen. So, anyways, that's enough about me. Today's episode is about Michael Maestlin. I hope I'm saying that right because I believe some of the spellings of his last name start with an O. So, I don't know. Give me some corrections in the comments if you know, though. Anyways, so Michael Maestlin was the mentor of Johannes Kepler, and he'll be a great pivot in this season as we go from Tycho to Kepler, and also he's often forgotten. So it's just nice to give a little bit of recognition to some of the people in the middle of this whole scientific revolutionary age, I guess you can call it. So Maestlin was born in Göppingen, Germany. I know I butchered that, but just had to say it for the record. So that makes him a German astronomer and mathematician. He was born into a Lutheran family, or Protestant, you could say, and he was the middle child. He began his post secondary education in Tubingen University. Again, I'm definitely butchering that because I know the German language has a lot of accents that I'm definitely not reading into. So, yeah. At Tubingen University, he was mentored by Phillip Apian for his master's studies, and it is believed that Apian taught Maestlin Frisius' arithmetic, Euclid's elements, Peuerbach's Theoreticae Novae Planetaris, which I think is something that Tycho or Copernicus also read into, and the proper use of geodetic instruments. Now, that's a lot of topics we haven't ever talked about, so let's talk about it. Why not? Frisius was basically a champion of applied mathematics. He was more into the navigation and cartography stuff, but a lot of that kind of work that he did had a lot to do with applied mathematics, and so I believe he wrote about quite a lot of arithmetic principles, which would have been taught by Apian. Euclid's elements had pretty much everything to do with geometry, as you would assume with mathematics in the Greek age, like Pythagorean theorem, and that sort of stuff. And, spherical geometry as well. So then we have geodetic instruments, which is, like, when you say geographic, it's geography. Well, what kind of study is geodetic, or what kind of study does geodetic have to do with? Well, it has to do with geodesy, and basically what geodesy is the science of measuring the geometry of the Earth. So what we mean by the proper use of geodetic instruments is just, proper application of instruments at the time to do some Earth geometry. So, yeah, that's all fun. In college, Maestlin read Copernicus's work and revised Prutenic tables based on his model. And as we will find out, he is one of the few scientists to have accepted the Copernican model. I believe the exact number of the total would be 10. And yeah, so he's pretty much one of the 10. After he graduated from university, or really finished his studies, he continued to work in theology and do some tutoring, but then for, religious reasons, I guess, he went off to become a deacon. He got married and he had children, but he came back eventually, so that's not the end of the story. In 1583 or 1584, I don't remember, he was named the professor of mathematics at Tubingen. And again, I'm definitely saying that wrong. He also taught trigonometry and astronomy, which is when the story of Maestlin mentoring Kepler comes to fruition. And another significant thing that happened during the 1590s in his biography is that the first calculation of the inverse golden ratio was written in decimal form by him to Kepler in a letter in 1597. And just a quick side note, when Maestlin taught astronomy, he used to use books containing geocentric theory, which is a bit odd because, he fell into the idea of heliocentrism. But he did end up incorporating heliocentric ideas in other ways, just not a textbook. And yeah, otherwise the rest of his story has a lot to do with his work, and there's not much work that Maestlin did without Kepler. So really what this episode is going to be is a brief set of things that he did by himself, and kind of setting a little bit of context as to the joint work that Kepler and Maestlin had together. So yeah, let's just get right into it. Let's start off with the Great Comet of 1577. And I know we talked about this with Tycho, but while Tycho was busy observing it in Denmark, Maestlin was observing it in Germany. And his observation of stellar nova, I believe, can even go back to 1573. So by the time he's observing the Great Comet of 1577, he's a bit experienced in his observations, and he's out in Germany doing his thing. And he found out that the comet had a sun-centered orbit, like a little bit like Tycho. And he showed that the comet was further away than the moon, which contradicted the accepted teachings of Aristotle, because he said, outside of the planetary rings, everything is fixed. And the comet disproved that to him. More specifically, he said that the parallax we observe when looking at planetary motion is not present in the nova of the time, and so the nova must be outside the planetary spheres established in the Copernican model. Maestlin was also the first to compute the orbit of a comet, and he spent the 1580s writing his own edition of an astronomical book, Epitome Astronomiae. And this one is different from the epitome that Copernicus is going to write, which I'll just mention now. It has 6 editions, but unfortunately its contents are very understudied because it was inferior to some of the other work he did, and that's talking about the work that he did with Kepler, because really the work that Maestlin did by himself is definitely not given as much attention. So in 1587, Maestlin published a manuscript entitled Tabula Modus Horari. I hope I'm saying that right as well, in which he gives the daily motion of the sun in hours and minutes with its positions in 2-minute intervals. So that's also something that he did in the 1580s while he was teaching, which, he had like 47 years of experience in. He was writing a whole lot of stuff, manuscripts, astronomical books, and we're going to soon learn about some tables that he was working on. Maestlin was a spherical trigonometric expert, and we've discussed why that can be important with Tycho's use of kind of spherical geometry for the Greek algorithms. And Maestlin was able to spot 11 stars in the Pleiades cluster with the naked eye and sketch them. As quoted from online, Maestlin published the first correct explanation of earthshine, pale illumination next to the lunar disk crescent due to reflection from the sunlit Earth. So yeah, first one to properly define some of the reflected light off of Earth as earthshine. After completing his astronomical book and a couple of years teaching, as we've stated, he became Kepler's teacher. And it's claimed to be super secretive, but it really wasn't. And yeah, from there, as Maestlin taught him about the heliocentric system, a system it became a system that Kepler took for granted in his writing of Mysterium Cosmographicum, which is the joint work of Kepler and Maestlin. I don't think when you give a quick search as to, or if you like quickly search Johannes Kepler's work and read into it, you probably won't see Maestlin's name pop up a whole lot, but it really was both Kepler and Maestlin. There was a lot of contributions that Maestlin made. First of them is the tables that appear in, I believe it's the appendix, and yeah, this is how the quotation goes. Kepler's publication of Mysterium Cosmographicum was supervised by Maestlin, in which he added his own appendix to the publication over Copernican planetary theory, with help from Erasmus Reinhold's Prutenic tables. So yeah, he contributed in that way to the work. Kepler's discovery of planets' periods in relation to the distance from the sun was done with the help of Maestlin as well, and Maestlin spent lots of time researching the sun, moon, and eclipses on his own as well. In his 1596 work, which is kind of in line with when he starts working with Kepler, that work is almost entirely about the sun and the moon, and is often referred to in Kepler's 1604 work Astronomie pars optica. And in 1604, this is a nice little side note as well, he observed another nova, and instead of making his observations public immediately, he worked on writing about it, but it was never fully completed, and that occurs pretty frequently across his career as an astronomer. I know he had like at least 2 or 3 incomplete works based on some of the novas that he was observing. And yeah, that is a very, very brief description of the work of Michael Maestlin. And as I've tried to make it obvious, he doesn't have much to show for himself, but a lot of the work that he did is significant, and we cannot forget his contribution to what is going to become some very, very revolutionary work with Mysterium Cosmographicum and the work of Kepler. So, yeah, dropping in to give you that lovely information on the man himself. If you enjoyed today's episode, I would sincerely appreciate a subscribe on YouTube if you're listening there. If you're listening on Spotify, I'm happy to see you listening on Spotify, and hopefully you'll give me a follow. And yeah, until we talk about Kepler and the next episode, I will see you all later. Peace.